Okay, first step is to visualize. And let's take a look. I'm going to graph one thing at a time. And let's see what we got over here. I'm going to graph this first. And I'll put an XY axis down. Give me 1 second. I have to erase this over here. XY axis go down like this. And let's see, that's a line. Y-intercept of 6. And an x-intercept of 6. And the line looks sort of like this over here. That's good enough, all right? X equals 0. Well, that looks like this over here. All right, so x equals 0. And this over here is y equals. This line over here is y equals 6 minus x. All right, let's do the other one. This guy over here. Now, before I do that, I would like to know the point of intersection between those two lines. So let's take a look at it. And the way to do that is just set them equal. So you get 6 minus x equals 3x minus 2. This would give me 4x. Add 2 to both sides, I get 8. So x would equal 2. So the point of intersection between those two lines, this line and this line, is going to occur at 2, comma, right? That's where the x is. And pick any relationship you want. And I'm going to pick the second relationship. So 6 minus 2 is 4. So what do I know? I know that there's a point of intersection at 2, 4. So I'm going to kind of ballpark it. I'm going to say over here somewhere. And this is the point, 2, comma 4. And I'm going to graph this line out now. Y-intercept of minus 2. So maybe something like this over here. All right? Now, what region are they talking about? This region over here. What do they want to do with that region now? They want to rotate that region about the y-axis. So let me draw a representative rectangle in like this. And I'm going to rotate that about the y-axis like this over here. And that's going to be done by a shell. So I'm going to draw a picture of that rectangle. It looks like this over here. I know the differential is dx, by the way. The top of that rectangle is going to be the curve y equals 6 minus x. And the bottom of that rectangle is going to be y equals 3x minus 2. The height of this is going to be the upper, 6 minus x minus the lower. And that doesn't too bad, right? What do you get over there? Do we get 8? Let's see. Minus 3x minus, that's minus 4x, right? Yeah. Okay. What are we going to do with this rectangle? Rotate it, and we'll get this elongated box over here. The understanding is I need to know this dimension, and that's going to be 2 pi r. That's the circumference of this thing over here. And what's that going to be? Just the x value. So it's 2 pi x. All right, let's write this down now. It's going to be an integration. We're going to start the integration at 0. We're going to stop the integration at the point of intersection, which would be 2. We're going to do this dimension first, 2 pi x times. Now we're going to do this box over here. And what's that going to be? Well, the width of the box is dx. The height of the box is 8 minus 4x. And what do you get there? dx, right? Let's take a look. I'm trying to simplify that integrand, right? And looking at it, I guess what I could do is I guess I could factor some things out. So I want to point out what I'm going to factor out here. Certainly a 2 pi. And from these terms here, I'm going to factor a 4 out. Let me be careful here. So 2 pi and a 4 would be 8 pi. 0 to 2. Well, let's see what you get. Factor a 4 out. You would get 2x minus x squared dx. All right, pretty simple integration to do now. What do you get? You're going to get 8 pi. Let's see, you would get 2x squared over 2, which is just simply x squared, minus x cubed over 3, limits of integration 0 to 2, 8 pi, 2 squared is 4, minus 8 thirds, minus 8 pi. Well, that's going to be 0, so that's pretty simple. So what do you get here? Let's write this down. 8 pi, common denominator of 3. And let's see, you get 12 minus 8, which is 4. 4 thirds. And what do you get there? You get 32 pi over 3 for my final answer. Let's look at the key, see how we did. I did get this. Certainly, if you want to look over the typeset material, indicate that we got the same integration as well. Thank you.